Hello, and thank you all for joining us today for our web conference, Always On Analytics for Always On Manufacturing, sponsored by Software AG and hosted by Supply and Demand Chain Executive. I'm Barry Hochfelder, editor of Supply and Demand Chain Executive magazine. Our mission is to provide intelligence and decision-making information for executives and management professionals as they enable the supply and demand chain for competitive advantage. It's our pleasure as part of that mission to present today's web conference. Slides will be appearing in your screen console accompanied by live audio from our presenters. Those slides will update as he moves through the presentation as in a typical PowerPoint. Now we want this to be an interactive forum and we've reserved time at the end of the presentation for a Q&A. You can submit any questions you might have during the conference by using the question box area on your screen and we'll try to answer as many as possible. If we don't get to them, the remainder will be answered by email following the event. Now, please note also that we'll have an archived version of this seminar posted on the Supply and Demand Chain Executive website at www.sdcexec.com about 24 hours from now. All right, predictions about how the Internet of Things, IoT, would affect manufacturing in 2015 were everywhere in January, but how many of those are panning out? Our speakers today, John Crupi and Sean Reily of Software AG, will tell you how manufacturers worldwide are using real-time analytics to leap ahead on the promise of IoT, whether unprecedented visibility into the supply chain to maintaining competitive advantage by developing top talent. You'll learn about supply chain resiliency that offers rare certainty amid risk, 3D printing's critical role in manufacturing strategy, and core IoT capabilities employed by the best of the best. John Crupi is CTO of Visual Analytics at Software AG, where he guides development of the real-time visualization and intelligence software that provides the foundation for the company's digital business platform. John has more than 2 decades of experience in object-oriented and enterprise distributed computing. Sean Reily is Director of Manufacturing Solutions for Software AG and supports the Americas by creating industry-specific solutions and by working with the company's largest manufacturing and supply chain customers. Sean's focus areas include value discovery and enablement, process improvement, financial and economic modeling, and collaboration enablement. And now, let me turn it over to Sean Reily. Sean?
Thanks, Barry. Appreciate it. So data feeds are always giving data, and they can't be taken down right now, so you can't be taken down. There just isn't enough time in the day to provide that analysis on that data. Additionally, orders are taken from around the globe. They're received constantly, and in addition to those orders, more and more types of data are coming in than ever before, such as positions of shipments of your products and components around the globe, and sensor readings from connected sensors. And these sensors are located in your production or your distribution operations, inside of your suppliers, and now most importantly, they're located inside of your customers' owned or leased equipment. And all of this data is available to you to tap into and continuously analyze. And it's coming faster than ever. This diverse data is moving in at scales and speeds that have been previously unheard of. And that scale and speed is continuing to increase exponentially. It's going to require around-the-clock analysis. And if you can do this, you'll be able to tap into efficiencies that weren't previously possible. Efficiencies that really can't be obtained when you're not performing this continuous analysis, because you have to do things like sleep or eat or not be at work all the time trying to analyze data. So you've heard of this type of analysis before. The concept of having always-on analytics or continuous analytics, it isn't exactly new, but what's different? The difference now is that companies are actually doing this. They're succeeding at this, and we're past the stage of just talking about it as something that's possible or something that is probably a good idea. Always-on analytics performs continuous streaming analysis on multiple data variables to deliver exceptions to you or opportunities for immediate management. It gives visibility to meaningful events, to give enterprises the ability to act predictively, and no longer react to issues such as a customer calling with the horrible question, "Where's my order? It was supposed to be here yesterday." Or a supply chain manager calling a partner saying, "When is this product going to arrive? Because your ASN said it should have been here by now. What's happening? Is it going to arrive in full, or am I going to have to take action to mitigate against it?" And that's the key. Always-on analytics supports always-on actions to ensure that those meaningful opportunities, or to use a term that's coined by Forrester, perishable insights, aren't missed and are acted upon so that they can be translated into value to your enterprise, your partners, and most importantly, your customers. So today we're going to talk about some current trends and their impact on manufacturers, their supply chains, and their extended enterprise. And while we're reviewing the agenda, we'd love to hear from you as to what you want to get out of today's webinar, or really what you're doing with the Internet of Things right now. But we're also going to review examples of how companies are obtaining new revenue, finding new efficiencies, and making supply chains that are resilient like never seen before, moving past supply chain visibility to prediction, understanding, and application of the right amount of management as opposed to the right amount of risk that's being faced. But we're also going to talk about how this platform is built to support all of these endeavors. And lastly, most importantly, we'd really like your feedback. We're going to leave time at the end of the session to have an interactive discussion. Well, as interactive as you can be on a webinar. But we'd really like to have a very in-depth question and answer session. And as Barry mentioned before, any questions that we don't get to, feel free to put them in the chat session or contact John or I directly, and we'll definitely provide you with those answers. So without further ado, what are some of the trends that we're seeing in the marketplace today? And while Software AG has created 10 specific trends, and I'm not going to cover everyone in specific detail, there are a few key trends that are definitely causing more of an impact than others. And those key trends are the rise of the Internet of Things and the innovation that IoT is allowing for manufacturers to really push through their enterprises. The increased amount of purchases of automation, the reshoring in emerging market conundrum. We've all heard talk about manufacturing coming overseas, pushing back to North America for some industries. And in other manufacturing industries, manufacturing is actually moving back towards emerging markets. And while automation is definitely affecting this, according to a PricewaterhouseCoopers study, the largest purchaser of automation equipment in 2013, and it's expected that this will continue in 2014, but the final numbers haven't been released yet, is China, which is interesting because previously China was thought of as this great low-cost labor market. But they're really seeing automation as a manner to manage not only their labor costs that seem to be rising, but also be able to make their manufacturing operations more resilient, more flexible, and be able to deliver better products at the right time and at the right price to their customers. And then lastly, the ever-important talent shortage for production and supply chain professionals. That seems to have been a trend that's been impacting the industry for the last several years. It's going to be a trend that's going to continue to impact the industry for the next several years. And when you put these trends together, they're really driving a specific set of requirements, and that is the need or the ability, if you will, to quickly identify customer or event issues and take action just as quickly. However, each action has to be specific to the event or that particular issue, as the one-size-fits-all model or the other model of relying upon a certain person inside the organization to, quote-unquote, fix the issue because they know how the system works is declining in their ability to produce value because of the precision and the scale required in today's world. More and more customers, again, are becoming much more pickier from this is what I want, this is how I want it, and that's occurring both at the consumer level, but also at the retailer level that's following that. In response, manufacturing operations and supply chains are morphing to deliver that level of granularity. So we're going to go into a example of exactly how we can capitalize on these particular trends and how always-on analytics enables these types of new scalable solutions with those particular trends. So what we're looking at is a great piece of equipment. This piece of equipment could be in your production environment. It could be in your distribution environment. It can be in your partner's environment. Or more importantly, it could be a piece of equipment that's owned, leased by one of your customers, or your customer is asking you, hey, we need help in maintaining this piece of equipment. And traditionally, there were two great methods. Well, maybe not so great, but there are two traditional methods at least. I have a corrective action issue. Something's broken, something's out of spec, I've gone outside of a control limit, I need my equipment to be recalibrated because it's affecting production yield and production quality. Or I've got a schedule that I'm going to follow from a maintenance perspective, and that's based on engineered standards, how long pieces of equipment should last. And based upon their estimated useful life, I'm going to start repairing them prior to that point because I don't want a catastrophic failure to occur, because that is driving just extreme amount of costs through my organization. So I'm going to go ahead and perform these maintenance operations on a preventative basis, which again is great if you're able to triage which particular machines are mission critical as opposed to which particular pieces of equipment are not so critical, and create a nice maintenance schedule around that. But because of the increased amounts of data, specifically the increased amounts of sensor data that's being driven by the Internet of Things, the industrial Internet, or over in Europe they're referring to Industry 4.0 to cover this particular section, there's a better way to go about doing this. And that is, number one, looking at real-time condition value. So you're looking at, for example, pressure, revolutions per minute, temperature, and comparing that to actual values from what is my planned degradation, what are my control limits, and what is my actual calibration requirement. And when I begin moving away from those particular areas, I want to know, because I want to be able to take action, which is great because you're moving away from the corrective issue. You'll never be taken by surprise, and you're able to network huge amounts of equipment because of the ability to network them wirelessly. But it's still not quite good enough from I need to be able to take action consistently and get ahead of these issues. So by taking that data and continuously analyzing it and feeding it through a sophisticated prediction engine, you're no longer monitoring condition in real time alone. You're able to take that and predict remaining useful life of that particular piece of equipment, or all the particular pieces of equipment. And when you're able to do that, it has some very interesting dynamics or very interesting outcomes that are associated with that. First off, from an operations perspective, you're moving away from unplanned or intrusive maintenance activities, which will occur, to absolutely planned or coordinated or synchronized activities at your customer's site. So it's no longer I have to schedule a technician to be out at your site tomorrow because we have a particular issue that we have to deal with right away. It's understanding what the particular schedule is or need of your customer, what your remaining useful life is, and being able to understand the impact of performing that particular operation at a time that's most conducive for either your production environment, your customer's production environment, or your supply chain requirements. These types of continuous streaming analytics or always-on analytics also allow you to do some interesting things from an inventory standpoint. Because you're predicting when you're going to perform these operations, you no longer need big piles of inventory, big piles of spare parts hanging around in the back rooms of shop floors, big piles of replacement parts in distribution centers around the country. You're able to eliminate that because you're able to combine those streaming analytics requirements from a what do I need to repair in the future with historical data, such as how long is it going to take me to get this particular component and when am I going to need it? So you're then able to synchronize the arrival of your technician as well as that particular piece of inventory because you're able to predict what's going to happen in the future. And lastly, and most importantly, you're going to be able to move from I have a customer that's going to purchase this piece of equipment. I'm going to sell it to them or enter into a capital lease with them for it. Now equipment can be owned, operated on a throughput, quality, and availability model. And the best part is there's transparency to everyone. The customer has transparency, the enterprise has transparency, and it allows you to ensure that everyone understands and sees the same type of actions that are occurring, and there's agreement upon those actions. And that is what allows for that type of pricing model or cost model to work. So John, the Chief Technology Officer of Visual Analytics for Software AG, is really going to discuss the key pillars of how to obtain these solutions faster and to ensure that as you build out these solutions, you're able to leverage technology in the best way possible. Also, during this time, please feel free to submit questions through the question and answer session while we're reviewing the presentation. We'll absolutely get to them at the end of the presentation, but let's go ahead and feel free to submit now. So, John?
Thanks, Sean. So now we're going to talk about how do you actually make this happen. And some of you may be thinking, this looks like great stuff, especially if I can start getting answers quickly. And when it comes to real-time data and real-time analytics, streaming analytics, it really does require a different set of tools and architectures and platforms. When we're talking about connected things, we're actually talking about temporal data and things that internally with sensors are always changing. Now, it could be as simple as something online or offline. It could be more sophisticated as GPS location being updated every half second, or it could be temperature, voltage, distance. It could be anything that any type of sensor can push out readings for. Anything from large machines to Apple Watch to connected cars to traffic lights. everything can be monitored that has sensors and can make that data available. The reason why we're so interested in this and we're excited about analytics is that the data from connected things tends to look the same. It has a timestamp, it has some sort of ID from what the device is, and then it has the name of the sensor and a value. And that may be simplifying it a little, but what the good news about this is that if the data looks and feels the same and has the same structure and it's timestamped and is temporal, then we can actually build analytics a lot faster. And not only can we build analytics a lot faster, we can answer questions a lot faster, and we could reuse architectures and build upon solutions without having to really worry about data structures like we have to do in traditional BI. Now, just to give you an example, if I'm looking at oil wells, I may have my different oil wells that are pushing out different sensor information with different values. I could have traffic lights that have timestamps, and the sensor is the sound, the temperature, the lumens pushing out, if it's how long it's been running. It could be even something as simple as me. If I'm putting out information and maybe I'm monitoring my heart rate and temperature and the steps and my glucose level, and you can imagine all the new type of wearable sensors that will come about, it's all really looks and feels the same because it's time-stamped and it has a whole bunch of information that's constantly changing, and it's not just from one system or one person or one thing, but it's from everything combined. And this is why when we talk about always on, we're talking about the ability to capture this information, and the value of it is that being on and being time-based is in essence a dimension in and of itself that's important to understanding. So when you're talking about SLAs, or you're talking about performance, or you're talking about competitive advantage, you can look at this information as it's happening and you can start getting answers to those questions. Another good thing about this is that the visualizations, what you see about what is happening, is now come to the point finally with HTML5 and newer browser technologies that we could look, the CIO may be on a tablet while an operator may be in a portal and an analyst may be in a tool looking at the same data live and historical blended and getting different types of analysis and information. This is the beauty of this, is that no longer can we build systems that just analyze data and then submit out PDF reports for historical, but when we're doing live, always-on analytics, we can make this available to everybody and in different ways and in different levels. And this is what we have to do anyway today. We have to be able to support mobile just like anything else. We're not writing to any single platform anymore, and everybody expects that the system is always running and always on. Now, in order to do this, any good system requires a good architecture. One of the things that we've learned is that there are 4 pillars in supporting real-time analytics. And those 4 pillars really drive the architectures that are being built and supporting the types of applications we're talking about. Now, you may be thinking that some of this may sound analytically like BI or what you've done in the past. The difference, as you hopefully can start seeing here, is that we're really talking about data that's constantly moving. So the pillars that we're talking about is we're talking about high-speed sensor hub. There has to be a way to ingest all this information. The information is not going to stop. Maybe if you have one engine that's pushing out information, maybe the engine may stop. But if you have thousands or hundreds of thousands of millions of things, some of them or all of them will be running at any point in time. So data will always be coming. The hub is the ingestion point, and it's also very important for cloud because cloud is a perfect environment to support ingestion because of its scale-out architecture. The streaming sensor analytics. I should be able to do analytics of data on the way in. If I want to analyze data, I should be able to analyze it as it's coming in, but I may be also doing analysis for future reference. So if you have the ability to do streaming analytics, not only can you do analytics and look at the live results, but you could also process and speed up the results when you're looking at historical data in the future. And we really do have to leverage in-memory compute. We can't just rely on databases to do this. We've tried. Databases aren't fast enough to support this type of analytical interactive query. And plus, a lot of the operational databases that are out there today just weren't designed to be interactive. And lastly, real-time visual analytics. Everything we're talking about is seeing what's happening. Sometimes just seeing the trends of things can give you analytics. Sometimes it's a lot more sophisticated, where the analytics, the visual analytics, actually has predictive analytics in it. So it's very important to really keep thinking about these pillars as we talk about the architecture. How does this thing flow? Well, if you think about it, a sensor really can be anything that provides information of something. I'm particularly interested in Apple Watch because I think for the first time we're going to bring wearable computing to the masses. But it's not just the watch. It's the ability to monitor things and all the sensors that are built in, and in real time, because it'll be connected to the internet. Now, whether it's coming from a watch or it's connected to Exida and machine to machine, or MQTT, which is a protocol for IoT, or maybe some proprietary API, doesn't matter. That data will keep pumping in to a cloud hub, at which time it's analyzed and processed. Now, there's a lot of talk of putting analytics closer to the edge, and that edge may be closer to the device itself, or it could be at the ingestion site on the hub. So what you see, there's just a visual of that. We could actually move a lot of the analytics or partial analytics over to the cloud so that we do more processing there. But ultimately, you want to get the data in, whether it's your data center or hybrid cloud, whatever it may be, or full cloud, is that as the data is coming in and you want to be able to get it, you're doing the sensor analytics, the results are being put in memory or also being written out to data lakes, and you're visualizing, and this never stops. It continues on forever and ever. And that is somewhat of a nightmare for architects. Now, although we know that the web is always on, there are systems, and you may go to your banking systems where they say they're going offline for a bit. Well, when it comes to this, you have to be working and going. And now that means that in order to support this, you see that the live data and the sensor feeds will be coming in. Now, some people think that when we talk about real time and we talk about sensor and IoT data, that it's instantaneous or, sub-second. The fact is it doesn't really have to be, and in many times it isn't. So we may have data coming in every second, every 30 seconds, maybe even every few minutes or few hours, but you multiply that times thousands or hundreds of thousands or millions, and all of a sudden you have just a tremendous amount of data coming in. Well, as the data is coming in, three things happen at that point. One is that it can go into the streaming analytics and be processed. Two is that it can go into data storage, and you see more and more talk about big data and data lakes where all sensor data is being sent to Hadoop or some sort of storage and kept there, not just for archiving, but actually to pull and process for historical analytics. And then as the data is pushing through and analytics are being calculated, those analytics are further pushed back into in-memory or storage, and then we're visualizing this. So as we see things happening, we are able to visualize the raw data coming across of the performance and the sensor data, and also the analytics on that information. But then, in order to put the context, we may want to see how performance is in the last hour compared to how it was 3 weeks ago. And so the ability to blend in historical analytics with the live analytics is really the key here. So as you blend it in, you're looking at comparisons, you're looking at seasonality, you may be looking at the past 3 minutes compared to the prior 3 minutes or the current 3 minutes. And then you take action. And that action may be doing something, initiating a service ticket. It could be going and asking for more information. And this cycle just continues. And not only do we have to have an architecture that supports this type of environment, but we need to have an architecture that supports visual analytics so that the user can ask questions and the system can go get more data and put more context around that. So it becomes very exciting, the types of things that we can do. We think all the stars are aligned now with technology and adoption of various technologies so that we can do these sorts of things that even 5 years ago would have been difficult. But now we're able to do these in a standard way, and we can do this at internet scale. So Sean, I'm going to hand it back to you and have you talk about some use cases and specific examples.
Great. Thanks, John. So John did a great job of covering the platform. We've talked about a predictive maintenance example, but now we're going to get into logistics and supply chain use cases that are also leveraging that same platform. So we're going to look at a logistics provider. And this particular logistics provider that we're talking about is a port operator. And they're typically monitoring about 4,000 ships that are coming into their particular port at any time. And they're receiving about 1,500 updates per second from those particular ships. And they're analyzing that data to continuously calculate new ETAs when those ships are crossing preset boundaries around the world and they're entering their ports. And this is where we originally talked about the always-on analytics as well as the always-on actions. The action that's occurring are twofold. Number one, the ships are provided instructions based upon their estimated time of arrival and port status. And why that is driving value is the ships are saving huge amounts of fuel because they're being told to slow down. Come in at half steam, because if you come in at full steam, you're going to arrive and sit in port for 3 days. So instead of sitting in port for 3 days, just go a little slower out on the ocean, arrive, and we'll be able to pick you up and unload you in a very synchronized and very exact manner, so you're not sitting here making a queue. Secondly, these actions, as well as the analysis behind the actions, are being visualized in a state-of-the-art command center inside of this port, or, depending on the particular user, on their mobile device, so that the operators of this particular port understand what's happening at all times. And if they receive a message that they have to look into a specific event or issue, they have the contextual data with them to take the right action at the right time. So this particular operator has seen a 300% increase in the number of messages per second that they're operating in real time. And again, they're seeing a significant reduction in costs, both from a wait time, a congestion time, but also from the amount of fuel that they've been able to save the companies, the shipping companies that are using their port. And most importantly, they're going to also be able to synchronize the container arrival with their handling and transfer assets, so that they're not wasting time of either the asset waiting to be unloaded or the asset that's waiting to do the unloading. They're both perfectly synchronized with each other based on what's happening right now. The second example we're going to look at is exactly how smart logistics can help support the concept of supply chain resiliency based on being able to dynamically replan routes. And those routes can either be over the land, they can be over the sea, and that's all based on what's happening, from whether it be a weather perspective, a traffic perspective, or a changing customer requirement perspective. By being able to continuously analyze what's happening both with the asset in motion as well as the requirements for that particular asset, this particular operator is able to re-optimize their trade lanes in real time and understand that their rerouting decisions are being supported by data in the form of customer requirements, by data in the form of what's happening to that particular asset, what's happening to the inventory that's on that particular asset, which is extraordinarily important when we're dealing with cold chains or time-sensitive materials. It allowed this particular organization to create agile trade lanes that allows them flexibility from a pickup, delivery, and providing their customers with real-time visibility into where their assets are around the globe. The results that were generated were, first off, a significant cost improvement because of the efficiencies that they were able to attain. But secondly, they were also able to expand revenue as a logistics provider with their manufacturing customers because those manufacturers were able to utilize more of their services at a lower cost level. So while that's great for a logistics provider, how can we specifically drive supply chain resiliency for a manufacturer? And let's take an example of a manufacturer in the hardest issue, which is I'm a manufacturer and I have a just-in-time delivery environment. That's the program that I want to implement, that I want to run. And unfortunately, events are constantly occurring that I have to deal with. So we have a new collection of sensors, and those sensors are providing real-time production yield. Those sensors can either be from suppliers or from the enterprise itself. So this use case works bidirectionally. Those particular sensors are, again, providing this yield to an in-memory cloud, and that data is being combined in a continuous analytic manner with predictive weather impacts and predictive logistics disruptions. And that really, first off, from a weather prediction standpoint, it gives you the ability to understand what uncertainty is lurking out there, as well as the ability to appropriately hedge against that. Because you're taking the correlation of weather forecasts, real-time weather forecasts, and its impact on your operational requirements. Operational requirements being, what do I need to produce? What do I need to ship? What are customers ordering from me? You're also able to understand and correlate in the likelihood of events and the likelihood of operational events. So you're looking at, okay, I'm receiving customer forecasts. I want to understand, will these forecasts change? Will the demand, the real demand I'm seeing, change or fluctuate from what I have planned or what I expect? And how can I correlate this against the weather that could be impacting my supply chain at large? This gives you the ability to really find the balance between hedging against risk and adding operational cost. Because, as we all know, you can fix any problem with enough inventory. The only problem is chief financial officers get really upset about that because inventory is extraordinarily expensive to keep in big piles around the globe. Additionally, when you're looking at predictive logistics disruptions, you're able to predict, so not just calculate a simple ETA, but you're able to predict transit times, future disruptions to those transit times, and that's based on not only the continuous analytics that's feeding that, but also your historical data and the correlation to your current physical state. And again, it gives you the ability to find that balance between what amount of risk do I need to hedge against and how much operational cost do I have. And that's critical because the combination of the continuous analysis that's being performed as well as the accuracy of the prediction models generates that. Most importantly, this allows you to understand what are my real-time JIT requirements based upon how can my supplier send me product on my production yield? Or more importantly, is my production yield going to be impacted by the actions that my suppliers are taking from a production standpoint? Am I expecting quality issues to occur based upon the data that's being sent out to that in-memory cloud that I'm continuously analyzing? Will they actually be able to fulfill my order because I understand what their production capacity is from a historical perspective? I understand the amount of time they have to complete that production, and I understand what happens when they try to rush that production from a quality standpoint. And then lastly, how can I generate real-time responses that are supported by contextual data that allows me to make the best decisions possible without adding an undue amount of cost to the situation or accepting an undue amount of risk? So we've covered 4 different use cases, and we've got approximately 17 minutes left, and I promised plenty of time for a robust Q&A session, and we're moving to that. But I wanted to quickly cover who Software AG is. Software AG is a 44-year-old German software company, approximately 1 billion euros in revenue, with a wide and diverse customer base. If you're curious about how do I learn more specifically around what we've talked about today, on softwareag.com, there's a wonderful tool there called Resource Center, where we have wonderful white papers, briefs, fact sheets, such as the Forrester Wave Big Data Streaming Analytics evaluation from 2014, as well as other pieces of literature you might find interesting, such as optimizing the digital supply chain or optimizing the digital factory. Additionally, we're going to have another webinar on the 21st of May where we're going to specifically show how you're able to move from monitoring to prediction to support a predictive maintenance requirement. And by show, we're actually going to demonstrate how the product works, as well as show you a real example of the application of that particular product. Moving back to Resource Center, we also have nice videos online that you can learn from. For example, Mike Galtieri from Forrester is discussing streaming analytics. And if you want to email fast results at softwareag.com, we'll be more than happy to send you the new book by Dr. John Bates entitled Thingalytics. Dr. Bates is a pioneer in streaming analytics, amongst other things, and he is the youngest professor in MIT history. So while you know where to go, you know what information you can gather, we'd love to hear from you as to what you're doing with what you're doing now inside of your industries, and we'll go ahead and go to the Q&A section.
All right. Thank you, Sean and John. Great information there. And folks, there's still plenty of time to get some more questions in, so please go to the Q&A section on your screen and send them in. And we're going to do a poll question now, if you don't mind. What's your company's current use of IoT? We're completely connected but having trouble making sense of the data. We use some sensor data but can't access most of it. Our products have sensors, but we're afraid to turn them on. And nothing in our company has the ability to connect. So take a few seconds and mark your answer, and then we'll take a look at what you folks think. All right. Here we go. Anything on there, Sean or John, that surprises you?
No, Barry, but I'm glad to hear that no one is afraid to turn on their sensors. That's always that's always important. Fear of the unknown is usually the biggest challenge. It's very true that, and I'll let John lead a brief discussion on this topic, which is we have some sensor data, but we can't access most of it. And access is just as important as analysis. Specifically, when you look at a supply chain or logistics perspective, there are points that can be termed as particular black holes, i.e. I've got a order that is out for delivery. It left my facility on time, but how do I know that it actually showed up? At some point, typically I'll receive a message saying that the carrier arrived, but those messages tend to leave some form of debate around actual on-time performance between a manufacturer and their customer.
Yeah, so
good.
Yeah, I think that these are consistent with a lot of things that we're seeing. We use some sensor data but can't access most is very common, and the reasons that it can't be accessed could be many. The data may just not be available in a form where they can access it, and others just can't get it connected. But I think a lot of the connectivity issues will begin to change very quickly, especially since there's many companies that are providing easier ways for connectivity. The interesting thing is, number one, where they are connected but having trouble making sense of the data. This is probably the number one, not only complaint, but reason why customers will move to always on or real-time analytics is because they're required to know what's happening. And sure, if you have a few pieces of equipment, it's not too hard necessarily to monitor. But if you have thousands of pieces of equipment around the world or hundreds or millions, it's very, very complicated. And visualizing information about how things are running is extremely valuable. Providing analytics on that. And the analytics could be as simple as just knowing how things are performing over time, or if things are performance or capabilities that are required are not functioning well. Ultimately, predictive maintenance and preventative maintenance is key to being able to know about something before it breaks. But this is really, I think, where most of the innovations are going to happen, is being able to quickly make sense of the data, use new tools and new technologies in order to analyze data as it's happening. It won't be your traditional analytics style that's been happening for decades, where work is going on for 6 months to get some really interesting information. We're looking about seeing information as it's happening. And this is one of the reasons we're talking today, is because we're able to provide this capability today. And just even in the last few years, we weren't able to provide it. So now is the time to really start looking at these technologies and start moving in this direction.
Okay, good. Let's take a couple of go ahead. Good.
Yeah, so perfect, Barry. There's actually one quick question that I'd like to answer, and it deals with access from ship data if you don't have access to satellites, Wi-Fi, or cellular. And there was a comment made that it makes it difficult to track a ship if you don't have this piece of information. And the reason why I'd like to discuss that is yes, that's a good point. If the shipping company or logistics provider has a particular vessel that is not providing location data, it makes it extraordinarily difficult to track. However, at least it's been my experience that the majority of those vessels are now providing that data, and they're providing that data to ports. They're providing that data to the companies that own those vessels themselves, and they're providing that data to freight forwarders. And typically, those companies are allowing that data, those types of data, to be accessed via external APIs. So you're able to get that data not by going to the ship directly, but by going to that company's data hub and obtaining it again via an API. From the point where there's a ship that's not giving any data at all, then yes, you're relying upon the ship has left the port at X time. I expect it to be at this particular port X days from now, and if it doesn't arrive at that time, I need to take action on that. But that's one of the pseudo black holes we talked about that occur in shipment. But again, based upon the manufacturer's requirements, it might be tenable to operate with a company that provides that tracking information because they're fairly plentiful.
Good. Question here about data itself. The question is source and clean data from logistics partners, suppliers, etc. Seems like the biggest hurdle. Cleaning up the inputs, verifying accuracy seems to take up all the resources with little left for analysis. Does this solution help with that?
That's a great question, and if it's okay, I think John and I will both answer it. And I'd like, if possible, to John start about the cleaning the inputs of the data and verifying the accuracy, and then I'll pick up about the analysis resources, if that's okay.
Yeah, this data cleansing and really is just a reality and a pain at the same time. There's really no way around it if you have to do this. However, part of this information and looking at the information, there are faster ways to, when it comes to things like IoT or machine to machine, the data, the tooling provides a lot of capability to see anomalies and see outliers and actually see data that just may be wrong or dirty or however it may be represented. And in this type of environment, it doesn't make sense to do a lot of cleaning of information if the source of the data is somewhat reliable, but there is a percentage of data that may not be correct. Now, if you really need the data to be correct, then of course you have to invest in the cleansing of it. But sometimes with a lot of this information, especially temporal, you may have incorrect data at some points, but you may be able to use visualization and visual analytics to rectify those and provide you with information at a much lesser cost to you than actually cleansing the data. So at some point, you have to look at the cost of cleansing versus what you can see that gives you enough reality or real information and look at it that way.
From the analysis perspective, and this is what's slightly different about continuous streaming analysis as opposed to traditional spreadsheet-based, report-based, BI-based analysis, is that when you're performing analysis, you're really performing analysis on what actions do I want to have occur when events are detected. And most importantly, what are the events that I want to look at because they're going to be most meaningful to me. So from an analysis perspective, you're really kind of changing position from a what happened, how do I want to make sure that that doesn't happen again from an optimization standpoint, and again to a what is the data telling me historically that's happened, and how can I ensure that as I am ensuring that my analytic engine is operating correctly, it's identifying what's important to me and driving action that also creates value. And the reason why I bring that up is that type of analysis, again, is slightly different from how we've traditionally looked at supply chain production operations analysis as a historical perspective.
Okay, good. Thank you, Sean. Let's go to back to John with one here. In the smart logistics example that we covered earlier, 1,500 updates per second were being evaluated. What should the number of events be per second that we should be thinking about?
Well, that's a good question. This is part of the new style architectures, or we call it internet scale, where you find it very difficult to size these types of applications, because even though you may predict the number of systems that may be connected, the amount of data that may be unjustified or unsuspected, or just that you need more data or more resolution. It's if Gartner is right and the analysts are right about how many of billions of devices and things will be connected by 2020, you're going to start having to look at millions or tens of millions of events per second being processed. Now, it doesn't mean that you have to have a system that can process and take action within that time frame, but you have to handle that information as it's coming in. So the bottleneck will be in the ingestion side initially, which means you need a very, very strong scale-out available architecture, which sounds very much like what cloud provides. But even though we're talking about, I just said millions or tens of millions of events per second, who knows? Maybe we could hear that 100 million or 100, 200, 300 million in peak times may be the amount of data that's coming through. Those are numbers that are extremely high and are difficult to architect for. However, these systems should be designed to be elastic and to start thinking about the number of events per second in the millions, at least initially.
Okay, good. And we have another one that just came in. Really good question. Can streaming analytics, at least in some cases, essentially direct existing customer software to affect an operation, such as turning a pump on? Something that would not have occurred otherwise. And Sean, you want to take that one?
Yeah, that's a great question. And the answer is that's the ideal situation, is that your continuous streaming analytics detects an event. It sends a alert to trigger action. And that action can either be somebody has to do something from a manual perspective, or, again, in a production operations environment, it is turning a pump on. It's turning a pump off. Or in some instances with equipment that's now being made that can handle this, it's having the equipment or piece of equipment self-manipulate itself or perform self-calibration if it's a highly automated piece of robotics. And that's where the genius of streaming analytics comes in, as well as that type of analysis that I talked about previously, is you're really looking at what's my event. Again, in this instance, we'll say it's a fluid level that needs to occur, a certain fluid level. or pressure, and that particular level is not occurring. So the action is triggered by that, and the action is a pump gets turned on because the continuous streaming analytic engine signifies that a particular event has occurred, and this action has to occur. And that action can be automated, as we discussed, or it can be manual. So a very, very good question.
Okay, great. We've got a bit of time left, so we're going to squeak in another poll question for you. What are your company's goals for IoT in 2015? Develop insights from what's already connected, find solutions to the data silos that prevent us from connecting, or identify ways to manage the volume of data we get or are likely to get. So take a couple of seconds and answer that, and we'll do a quick review for you.
While you're taking a couple questions to answer it, a final question came in that I'm going to answer very quickly, and that is, does your software need to be implemented to tie everything together? In other words, a machine needs a new part, so does this order automatically go to supply chain, or does there need to be manual intervention? And the answer is both. It's an either-or example, depending on what you want to have happen. You can either orchestrate an exception management process that says, okay, I see that this particular component needs to be replaced. It's going to need to be replaced in 4 weeks. The lead time for the replacement component is 3 weeks, so I'm going to automatically place an order with that particular vendor and have it delivered to either the customer site or to my location, and I'm going to cite the particular delivery date and then, of course, track that in real time. Or it can be simply as a alert that's generated that gets the attention of a procurement professional or a maintenance professional or a customer service professional, depending on the particular situation, to manually order that particular component.
Okay, great. Let's have a look at our results. Goals for IoT in 2015, 60% of you say develop insights from what's already connected. 30% identify ways to manage the volume of data we get or are likely.
So I think we might have lost Barry, but we are 5 minutes past our guaranteed ending time. Again, thank you for your time and participation. We very much appreciated the opportunity to spend an hour this afternoon with you. If you have any further questions, please feel free to contact myself, Sean Reily, or John Crupi. And of course, we look forward to talking with you in the future. Thanks, and enjoy the rest of your day.